Hi, welcome back. So we are in chapter 4, FSP VO1 project, the outline workflow of the project. We have established so far the research question and we understand what we intend to do inside this project. Now it is time, as we said, to create actually the backend. This is a procedure that can be left off to the developer of the application completely ad-free and depends on the requirements. Sometimes maybe you need to work on the GUI first, like we did in the previous project, sometimes on the backend first. It depends on, actually, there's no a certain formula that you can stick to. So in this case, we decided to work on the backend because some of the things that we need for the GUI, whatever it would look like, it needs some establishment end of the day. That's why we decided to go ahead and visit the official website, the KEP, where Istanbul stock market companies are in there. And we wanted actually to make some scrapping on this website to extract all the sectors and their corresponding companies as well. Create that kind of a dictionary in JSON file. We are going to create two important modules, I think. They are going to serve as the main back-end connectors, so to speak. I'm not talking about the main window yet, but just only two modules. So the first module, maybe we can call scrap module. This is going to be responsible to just scrap the website, prepare the functionality for JSON, and maybe we can even add some extra functionality. And another one, maybe we can call it the data center to connect anything to it related to the interaction. So the main window will be token basically to this data center. You could see here the design have changed from the previous application. This is much more compact and much more focused. Now in the scrap here, maybe we need only one file, .py, whatever the name could be. Maybe scrap as well, doesn't matter. And inside this, we can create a main class, CLS, that is going to work on the functions of first maybe one function to scrap the website, one function to do some other things like preparing for JSON reading or loading or saving. And on the data center, here maybe we need two actually submodules inside. First one, maybe we can create module.py for the database, and another one, again, we can call it data center, maybe .py. One of them responsible to handle the database connections, and one of them actually to handle the event or to see what are the requests. In addition to that, preparing the information to be actually stored on the database in a proper way, because this is going to happen only one time. So we don't expect that KP or Istanbul stock market every day have a change on that. After this, we can start talking about the GUI. So let's go ahead basically and work on the establishment of these two different modules. Okay, so I am in the FSP main folder, just as we saw before. This is the CLI, and inside here we are gonna work on the data center, as we said, and the scrap. The UI will be working on it later when we work on the design or the GUI. One more important thing that we need to maybe advance enhancement on the entire functionality of the application is that to rely on something called the config file. Now, basically, what is the config file? There are some information. For example, take the dataset information. What are the important things like we have seen before? We need some inquiries. So we did this before manually, where we created actually inside the DB some functions like to retrieve, to insert, to do things. But that was like much more specific in a static way. So it was like one function is built to execute a specific order. How about if we create a very general function, okay, for insert, for example, into a data set, and we say, well, this function is gonna just receive what is the str, because we execute a string in fact, and maybe what are the values or the information you want to insert. And basically what happened whenever we want to insert something to the database, we call on this function and then we say, well, I want you to call this insert function inside the DB, and I'm passing to you the string that I want to execute and the information I want to insert. Same for retrieving. Now the question is, where are these str coming from? Well, it could be written directly inside the code where the execution is going to start, or as I am suggesting here, we create a config file. And what other information can be stored inside config? It's going to be a list of dictionaries. So basically there will be key and a value. We could like store a key, say retrieve all record in the database, something like that. This is going to be the key. And then we can write the official, the SQLite format, for example, retrieve all from a specific table. So we can write as many key and values as we want inside this config. In addition to that, we can write password, usernames, etc. So this config file, it is also for security purpose. So it's all depends on the way you want to handle. It's completely optional, but I just wanted to share with you different style or mechanism of executing your project. So in this case, as we said, we're gonna create this config file to be inside the structure or within the structure of the FSP module itself. Okay, that's why we have here the config.py. As you could see, the config.py could also concern some headers if you are doing some kind of scrapping. But basically, I just create a dictionary, as you could see, with key and values. So like username, password, for example, insert into a sector table or company table. And these are the information and the same string that we usually use. So later on in the code, when I write, instead of writing all this inside the code, it can be cleaner, neater, and much more organized. This is an alternative way of thinking about the operation. It will be left again to you. So let's go inside the scrap as usually. To create a module, we need the init, and we need the name of the submodule. So in this case, we're going to be working on scrap. And here we need just only two libraries that we need to work on. We need requests before OS and JSON. Here we create the name of the class called scrap CLS. And of course, in the instructor, we don't need something special here. So just pass on it. There are four functions that I have created here. The main one is the scrap KPI. Now, basically, scrap KPI will receive a URL, which is actually the name of the KEP official website. And in particular, we are interested to reach out to the information that we have seen before. Now, I'm not here again to teach you how to scrap a website, but this is a very simple task. It's not a big deal. Our aim is to create this dictionary. This is what we want. So it is a list that contains number of dictionaries. This is going to be our JSON file. As we said, we expect in every entry there is the sector name and the companies that are inside, and the companies itself is going to be the value is going to be another list inside that list number of dictionaries, where each one of them will have code and a company, code and a company. So I hope this is structured quite clear to you. This is the aim of this function, to actually output this. How to use a beautiful soup. There are many good documentation to do so. With just a quick, you can call the request and get the URL with empty parameter. Otherwise, you can pass headers in case if you are doing this quite a bit often, so to avoid any blocking on your IP. Then you call the beautiful soup, pass the request, and I need the content. Now inside this, I have all the information on the website. Now specifically, if you reach out to the websites we see, we are intent to actually reach out to two pieces of information. We need this sector name and we need the companies. The companies are stored inside what so seems to be a table or maybe some div. This class, we need it. And the next one is to reach out to this side actually, column type 7, etc. So we need this guy here. This is the general idea. That's why we say find everything that have this class name or this class name, and store them on these two variables, one for the sector name and one for the company name. Then we create an empty list. This is going to be the main list, as we said here. This is going to be the main list. Inside, we're going to create the dictionary. Okay, so we need to decide the length, how many actually field that we have found. Probably you will find like 70, 73, which actually correspond the number of sectors are in there. Now I'm going to loop inside. Okay, and then I'm going to do a few things. Number one, create an empty dictionary. This is the main dictionary here. Right, this is number one, the record entry I call it. And inside, I want you to create sector name and company name. I'm just following the exact procedures I wish to. So basically, I'm creating this and this. Okay, the sector is easy. Just directly go to the actual sector name and extract the text, and make sure to replace unwanted like slash and a new line. Then you retrieve exactly the sector name. Now the companies are quite a bit different story. Now the companies ourselves is going to be number of them, so it is going to be a list actually. That's why we're going to loop inside the company and find everything with these two pieces of information. One will indicate the code, the other one will indicate the company name. So if you go inside here, you'd see that this is number, and this is the code, and this is the name, code and name. These are the two information that we want. This is exactly what we did here. So we actually called on the code and called on the name of the company, and then we stored them inside in the form of the dictionary we want. Here we go, everything is in there. Then append that entire track or record into the IST list. Done. Then you try to open and create a JSON file. This is going to happen only one time, by the way. I mean, it's not going to happen every time. And jump and create this JSON file. Now, if you execute this function one time using a script or from the main application as you like, by passing, of course, the URL, you will end up by having this JSON file, as you could see, and the exact same structure as we expected. That's why we create a new function here we call return ist JSON. So basically what it does, it go to this particular file and return the information or the data inside. Why? Because later on inside the maybe the GUI, we will need to populate sectors or companies, so we can actually easily call on the return ist, and then we return the information. In addition to that, I created two more functions here: serializer save JSON and serializer load JSON. So these are two functions. One of them, as the name is indicating, to save JSON file and to load JSON file. We will have to actually deal with some of the functionality to read and load JSON file. That's why the first function expects you two important argument. First one, what is the source that you want me to read, and where you want me actually to save, because it's saving. And it's done the normal way of just saving by opening right and make sure it's a UTF-8, otherwise it will not read correctly, because here is a Turkish language, so the information is coded differently. It depends on the alphabet letter, so make sure to use the UTF-8 so the information will be correctly stored. And of course you're going to save to the a proper location as expected. Same for loading JSON, sorry. So you just give me the file path and I know how to read, and I will return for you the data. So that's all about Scrap, nothing special. Let's go ahead and explore what is inside the data center. We said inside the data center we need two important pieces of sub modules. The first one called the DP. You can see they are very clean: create, database, insert, and select. That's all. We don't need actually to interact much with the database. It's going to be only one time. Now, if you remember the structure of inserting, you could see just create the connection to the database. By the way, just before I forget, these are three important tables we need to create. The first one is going to be a table for the sectors, and the second for the companies, and another table, since this is many-to-many relationship, that connect the sectors ID and the company ID. So we're going to rely on this a lot, because when you click on one sector, we need to go and find that sector, what are the company attached to it. Or if I search by company, I need to pick the company and see how many sector this companies belong to. So either way, it's many-to-many relationship. That's why we need to create three different tables. So I create the three tables, the database, everything is ready. Now I can interact. So you could see the structure what I did. I said, well, give me the case you want to insert in a form of str. This is going to be a string, and give me the data itself. Now this information will be passed to this function in a general way. You could see it is not specific. So it doesn't matter you want to insert to any table. You just pass to me the string and I will execute. This is a very, very clean way of putting your code. You could see just a few lines. Same thing if you would like to can select as well. So give me the case, which is going to be a string. that is the SQL actually format search, and the case of the data, which is going to be actually, if you pass, I'm going to be selecting, it depends on, for example, retrieve for me based on this ID. Otherwise, if you don't pass to me, that's why I set it to none. Otherwise, I will just retrieve everything. So this function you see here, it retrieve either all, whatever is inside the database, or just retrieve a specific information based on a search ID. So we have covered now, we have the scrap, it's done, the information JSON is done, you have the database. Now everything actually is operating good and well in the back end. One more important thing is now to create the data center. Now this is going to be quite a bit larger and much more in details. Why? Because this is going to be the core connection actually between the GUI or the main window and every interaction either with database or retrieving things. Now inside the class data center, standard things to do, import some libraries that you need, and important things to observe that of course I need the config, and of course I need the scrapping and the database as well. Beside that, you need maybe some other functionality, maybe the map plot and etc. These for animation purpose. All right. So what is inside the data center? There are a number of functions. I have actually did my best to make the documentation quite clear to you. There are a number of blocks inside each one of them, actually, the relevant functions. The first block is just to work on returning all sectors from database or companies, etc. Another block actually to process the fingerprints, that the concept of the AI that we spoke about, and the last one actually to create sector companies and a relationship on database. Let's go ahead and review quickly the actual information of each of these functions. Look at the first function called creating companies. By the way, these functions are going to be executed only one time. It goes as simple by actually visiting the JSON main instinct from the scrap. If you remember here on the scrapping, we created this return symbol JSON, the big JSON file. And from here, actually, what we did, we first of all created a company empty list, and I say, well, go inside the big file of JSON. Just to remind you, it looks like this, the JSON file. Go inside here, and I want you to pick all the companies from the dictionary. Check out the format as we explored the code, the companies, and then create the company list. As you are done, I want you to go and actually save it inside a company JSON in the path of the data center. And of course, we reach out to the serialized save JSON inside the script that we created here, save JSON, right? Now I have a new JSON file, just hold the companies and their code. So code company, this is the format. Good. What we're going to use this for later, you will see. But for now, we create the companies. Same thing, we could create the sectors for the JSON file as well. Same format. So reach out again to the same exact instinct from the scrap class, return the data, loop over the sector, save it as a JSON file inside the exact same path, which is going to be like this, all the sector names. Done. Here we go. We have all the information of the company and the sectors. Now, what we want to do, we want to insert these into the database. That's why you could see there are three functions, one to insert to sectors, one to insert to companies, one to insert to the company sector, that is the ID alone. So to insert to sector table, first of all, I'm going to read the sector.json, which I have just created. All right, now I have all the sector names. Then I reach out to the scrap instinct to load that JSON file, because we have written, if you remember, function just to load JSON file. All right, so I have now all the data about the sectors inside this variable called sector data. Basically, then I'm reaching out to my config. I say, well, go and find out this string, insert into sector table. So if I go, where is insert into sector table? This guy here. There are information, insert into sector table, just the sector name and the value. So you expect this is the execution of SQL inquiry. So basically, we need now to provide the value. The value is the sector name. And don't forget to add this comma after this, because this is how SQLite documentation indicating. So if you don't do that, you will end up with an error. So basically, reach out to the database and reach out to the insert into table. If you remember, this is the function insert into table, which expect you to pass the str, the string, and the value you want to insert, and it's taking care of the rest. So simple, so clean. You could see it's a few kind of a line. I did not have to write the config or the inquiry here, and everything could have been messy. So this is a structure, is what I was talking about, much more cleaner, advanced, and industrial standard. Next, of course, you could do the same for the company. Go to the company.json, pick up all the companies with their codes, create now this tuple, which have the value and the key, I mean the code and the company. Now, which inquiry we want? Let's go to the config and let's look at this inquiry, insert into company table. So you look here, insert into company table, this need a company name and a code. Done. Now we have inside the database the companies and the sectors are inserted. The last table is the ID of the sector and the ID of the company, because it's a too many relationship, if you remember. Here is going to be a little bit tricky. Here maybe we need to go back to the original file, this big file that holds all the information, the sector and the list of all companies. So basically the idea was to reach out to this file, which is going to be an instinct from the scrap class, if you remember the first one guy here. And then I'm also creating instinct of the database later going to use. Now I'm reaching out to number of inquiries inside the config. One of them is insert into sector company table. This is going to be the last, of course, to insert the values. But there are two important inquiries here called selector from sector table and selector from company table. So if you get back here, select from company table, what are they retrieving here? Well, we go to select the ID of the sector, giving the sector name. So basically, I give you a sector name, tell me what is the ID of the sector. I'm giving you a company code and tell me what is the ID of this company. Because we said this last table is going to be company ID with a sector ID. So I'm looping inside this big file, JSON Istanbul data, picking up the sectors, creating that inquiry, going to the select table, passing and retrieving. Now I have the sector ID. Same, I'm going to pick up the companies, pick up their code, pass to the database, inquiry, retrieve. Now I have the company ID. Here we go. I am done. Finally, I'm going to insert these two pieces of information tuple inside the sector ID company, which is actually this last guy here. The three tables now are already populated, my database up and running. But the last thing just to observe is this create real-time price. What is this? Now, since this is a demo, I'm not going to create a fingerprint for each and every company. That is a user resource time consumption as well. This is just a demo for the idea. I have decided to work only on a sample for one company. In this case, I have chosen Turkish Airline. Okay. And the code of Turkish Airline is this guy here, THYAO. This actually function should be for every and each company and should be operating on its own different module. But just for simplicity, I wanted to show you that. Now, what are the information we would like to add to that fingerprint and the image we were talking about? Well, we only have the historical prices, as we said. To this end, I went to a proper place where you can download the past 1 year or 5 as you like. I just downloaded 1 year historical prices of Turkish Airline. You can get this one from any available source, all right? It's not hard. That contain date, open, high, low, close, and volume. These are the information we spoke about before. Now from here, what I wanted to do, I wanted the prices as the closing one, this price here, because later I'm going to use these prices to be actually graphing the real-time price of this particular company. I should have done this for each and every company if I want this to be a real industrial product, but this is a demo. That's why I'm just showing you on one company. So basically to do that, I went to the information of the past year and I scrapped down to create a new CSV file called the real-time price, which is if you open here, actually it's just only the price for the past 1 year. This is what this function does actually. Basically, you can open and then create the file. Good. Now let's move to the second important block, that is the fingerprint. That is the entire idea of the AI here. Now basically here I have a data that contain a price that have the open high price or over the day, the lowest price, and the close, and finally I have the range. Imagine I have this data for 1, 2, 3 for the past 250 days, which is around 1 year. It means I have 250 rows by, these are 5 features that I consider them as a feature. How about if I create some extra features actually here? What are these values? Well, I could think of, just for a sample, like say I have range, right? The total amount of range of trade of stock in a day. So I said, okay, go through the entire year and get an average range. How much the average range was trade for this company. Then go to each and every day here and subtract the existing range from its average and set the value here. So you will have a new values here. And then I went to say, well, check the close to the open difference and set value here. Then the open to the high difference, set it here. Then the open to the low difference, set it here. Close to low, close to high. So I added here some extra information just to fill up in 1 day. I don't have only 5 features, I created around 14 extra features. So now I would have 250 by 14 features. I want you to check actually if the closing of this day happens to be positive, it means the close was higher than the open. I want you to indicate this day particularly as a positive day. If not, consider it as a negative day. Afterwards, I want you to sum up the entire idea here, convert it into an image, and give the label based on the average between positive and negative. So either it's going to be positive or negative. So this fingerprint or this image, it will be labeled as a positive or as a negative according to all this information. Now, this is a complete demo. This is not something really academically could be proven that easy, but I'm just showing you an idea. So I decided to do that to create this fingerprint. I would have then by the end a kind of code image. I call it the fingerprint with a certain label. All right, so here we have the company fingerprint, basically as I have done. This is my aim to create this, and basically the information, how it's going to work out. First of all, reach out to all the 1 year information that we have, extract all the information of the open, the close, and everything in there, and just try to create these 14 new, 7 new actually features, because we have 5 before of that. So, and then start to attach them. And finally, actually, you will end up with this. I will leave reading this for you. It's nothing special here. So you have then all the information. Now I have 14 different features. Close them down and be ready. Now all the information here in this function, basically it will return the data frame. Now this data frame, I could literally go ahead and save it as an image, as a positive or as a negative. And of course, you're going to return the image. This function that I'm just showing you, it could be a class on its own. It could be actually a product on its own. It could be making money for you on its own. Just this is the general academic establishment. Finally, I would like to show you the return all class or return for company. I think these are features or information you should be able to read and understand by yourself. For example, this function here, just to return all the sectors. Later on in the GUI, we need to maybe populate a list widget. So we need to return all the sectors from the database. This is what it does. So connect to the database, return all the sectors. Okay, and of course, you're going to connect to the config. Basically, it's just collecting all the information from the sectors, as we have seen here, all the information. Same thing here, you could work on also returning relevant companies, depends on. So for example, I want to click on one particular company and I want to retrieve the information about the company. Because this is a demo, I did not really add any important information about any company, such as the market cap, some actually financial information, because it's just a demo. So I hard coded that inside the GUI for that purpose, just to show you the general idea. It should be actually just much more automated rather than static. And then finally, of course, you're going to have one more for company given an index. So basically just say, well, I'm telling you which company I'm searching for, and return the information from the table or from the database. Okay, that's all what you have to actually look for inside the data center. Now, what we have done, we have covered all the modules, the scrap, the data center, and we are ready now actually to work on the final module, and that is to design the UI or the GUI of the company. That is exactly what we're gonna do last for this application, and I will see you then.